So this one is easy for me. So check here. Can you see my whiteboard?
Yeah.
Okay, you can see the equation I'm writing right now, right? Okay. So pay attention to this. So this one you can become like this. And then right? Such that the following equation has two integer solutions. So like, for example, so first of all, they have two equations, which means this one have to be larger than 0, right? If it's because this is like a square, and then if this it should be larger than 0. It cannot be like minus something because this is square. So it cannot be equal to 0. Is this equal to 0? And then this equation only have one solution, which is 3. So and then this and then this has to be like this, right? So which means this square root has to be integer 2. So which means the something there has to be integer. And then this is like okay, but so we can say this, assume this, and you can so why it become like this? Because this is 4m. So basically you want to become like this. And this is equal to it's equal to 50. So that's how it works. So and then you can switch these two together. Vector 5. And then because n and m, they both are integral, and then two integral multiplied together should be 55, and the 55 could be 1 multiplied 52. And since n and m, they both are positive integer, so this is bigger, right? The second one is bigger, and also become like 5 multiplied 11. So you can do those kind of equation. And from here, you can get to know n is equal to, when you add together, it's the 56 divided by 2, n plus 4. So n is 56 divided by 2, 28. 28, okay. 24. This is -1. Oh no. Oh, I was calculating wrong. This is 15.6. This is 4 n plus 16. Yeah, n plus 10, 28, 27. So from this, we can get this, and then this is one of the answer. Another question would be, here, we can get to know, and then we add together 16, this is 16, and it's 0. It is like 3, but, so it's 2. It's 2 group. Did you get it? Am I clear with the procedure?
Yeah.
Okay. And what's the next one? I don't understand. What's the next problem? When you talk.
Number 17.
17. Okay. How many positive integrals a? It's a prime number. Okay. How many positive integers? It's a prime number. Okay. So basically, so you want this can be a prime number. So first, let's okay. So first, let's convert like this. This is like, it's equal to, because this is convert to, so you want to get this. This is wrong, right? Let me see. 6A. 6, 8. Okay. What's wrong here? Okay, because this is become the 6, 8. So from here you can get. Okay. So oh, it's a so this is right. You can convert this equation to this equation. This is prime number. What's the character about prime number? Prime number, which means it can only divide by 1 and itself, right? So which means so the final equation like this will be 1 multiplied by the prime number, right? And then so which one is 1? Like it should be like these two equations. One is 1, another one is that prime number. So maybe we can assume. Am I doing something wrong? I think I did. Oh, here, sorry. I know I did something wrong. Yeah, I was wrong here. Yeah, yes, I was wrong. Okay, let me see right. So it would be situation like this. So let's say we say this can be converted. Oh, and then let's say it says A is non-positive. So it's not A is not positive, and then that's not true, right? And then but so this situation, because what are getting A in this kind of situation are all negative number, which is not the same as the condition in the question. So this would be wrong. And then another condition would be this equal they convert. And then this will convert to then you're getting A equal to 2 and 1. Okay, and then when A is 2, then this number would be 4 plus 6 would be P would be 13. If A is equal to 1, then this one would be 7, which is right, right? And then okay, beside this 1 and the P, we can do -1 minus P, right? Because that's one of the situation. So we can say the same thing. Would be this one. So we go 1. And then this one. This can getting. So this is like A, it's like a non-number, right? Right. This is 4. So this is getting no number. This is the opposite. And from this number, we are getting, we cannot get any a number too. So this doesn't exist, only these two situations. So there are two integral. You get it? Okay. So that's all right.
Yeah.
Okay. Then let's talk about next chapter, which is Let me see. Can you see my book?
No.
Oh, you cannot see my book?
Oh,
Sorry.
yeah, I can.
Oh, okay. So we're gonna talk about triangle. This is called very important like geometry knowledge. Okay. Then so about one of very important is called Pythagorean theory. It's like, for example, a triangle. You have three sides, right? So this is A, B, this is C. This side called this is A and B. This like they they are like this A and B, like for the legs. A and B, they are part of this 90-degree angle, right? And then this is called hypotenuse, right? Why it's called hypotenuse? Because this C is the longest one of this triangle. So one of very important theory about this 90-degree triangle, it's A squared plus B squared equal to C squared. Okay, just remember this theory. So they give 4 ways to prove it. So you can spend some time to look at it. I'm not gonna explain further because the most important thing is how to use this equation for a 90-degree triangle things. And then we're gonna talk about several examples. So like, for example, look at the first, look at like this page, right? Like there are like A, B, C here. So A and B are legs. C is that hypotenuse, like longest one, right? He want to prove, this is called hexagon, right? Hexagon, because they have 6 sides, and those 6 sides are all side, the length is all time. It's called hexagon. And then S1, S2, S3, all of them are hexagon. And then all 6 sides will be equal for this S1, S2, S3, right? He want to improve. He want you to prove like S1 is equal to S2 S plus 3. How did he prove? Because like, for example, for any hexagon, S represent the area of this hexagon. So like, for example, if this is A, how to calculate the area for this triangle? We can calculate it. Like, for example, I can divide this like hexagon into this part, right? Into this kind of part, right? And then we can just this area of this hexagon can be this square plus this one and this one. So how to calculate the area of this one? So basically, this is 120-degree, right? 120-degree, if you put a straight line here, make sure this is like straight line, and then this is like this is like 90-degree from here to here. That's called height, right? And then how to calculate the height? Because this one is this one would be 60-degree, and then this one would be 30, right? And then this would be C. And we know if this is a triangle, this is 30-degree, then this one would be 60-degree. If this is C, like hypotenuse is C, and then the 30-degree, like opposite to this side, this is this is like half of this one. That's a rule. And then this is 2, right? Did you learn this kind of thing? Like if this 30-degree and then the side like facing to that 30-degree would be half of this hypotenuse. And then the third one, the second leg would be square root 3 divided by 2c. So remember this rule too. Okay, so let's go back here. So this one is A. And then this is 30-degree. So which means this height would be half A, right? And then this side would be square root 3 divided by 2A. Okay, so but since this is only half, the whole thing would be square root A, right? From that, we can calculate the area of this triangle would be, because the length would be square root 3, and then the height is and half of the 2, and then divided by 2, right? That's the area, and then the area of this one is equal to this one. So these two triangles added together would be 2, right? Would be, that's the area of this. That's the total area of these two angles, two triangles on the side, right? And then this is square root A, and then this side is A. This is like this is like not this is not square. This is like, I'll say this degree is 90-degree, and then this is like what's this called? This is called a square. The square area would be this side multiplied by this side. This is called a rectangle. The rectangle area would be two sides multiplied together. It would be this one. So the area of total this hexagon would be added together would be, right. So when I'm saying that, like any hexagon, if all these 6 sides are the same, and then their area would be right, and then from this equation we can get S1, it's for S1 it's each side it's C. S2 would be A square root. S3 is equal to, right? When you, so you can from here you can see so S1 from this 3 equation you can see S1 is equal to, and this C square is equal to A square plus B square. So right, this is S2 plus S3. So that's the answer. Did both of you get it? Grace, did you get it? Okay. Let's keep going. Talk to next one. Theorem 2. Okay. So let's do about. Okay. So look at the chart, the graph on the book. So this is S1. S1 represent the triangle, 90-degree triangle in the yellow part. So basically this part, like A and B, these two sides, when they work together, they interact with they cross together, and causing that angle, like crossing from A and B, they're 90°. And then this S2, it's like a part of this like how to say it, this is half cycle, right? This is like S2 plus S4, it's half cycle, and then S3 plus S5, it's half cycle too. He want you to improve S1, this yellow triangle, 90° triangle area is equal to S2 plus S3. So okay, so since this angle is 90°, so we can get to know a square plus c square is it's c square, and then so try to calculate the s plus 4, it's like when it's S2 plus S4 together, it's half of the it's half of the cycle, right? Area. It's on the left side, and then it would be right because you know how to calculate the circle's area, right? Let's say this circle, its radius is A, right? The whole circle area would be pi multiplied A square, right? But what we are getting S2 plus S4, that's half of the circle, so it would be divided by 2, right? But then under this kind of circumstance, its diameter is A, so radius would be half of the A, right? So we got this. The same thing for S3 plus S5, the same thing, right? It's so the right side of half cycle, the diameter, the flat circle, the diameter would be, so its radius would be half of the B, right? So that's the area. And then when we add this together, so when we add this right side together, side together would be right. This is equal to C squared. Okay, and then what else we can do? And then let's see, S2. Oh, okay. Okay. S1 is equal to right. I think I'm doing all right. Okay. So okay. So from this, we can also know right. And then okay. And then think about like look at the middle. That's another circle. Like S1, S4, and S5. That's another half cycle, right? And then so basically this represent S1 plus S4 plus S5. Look at the middle one, like the green plus yellow plus purple. That's the area, right? So this is So let's cancel. This is one. That's how it proved. Okay, are we good? I'm going to talk about the third one. Is it okay? Okay, so I think that's okay, right? I'm going to the third one. So oh, this one's easy. So he's saying this is this hypotenuse is square root 2a, and then this x, this should be x because this is 40 degree. This is 40 degree. So we can do like this. Right? Okay. So that's easy. Okay. Oh, the fourth one, remember, I just mentioned about very important. The fourth problem, the fourth theorem. So we just mentioned about if this is triangle 90 degree, this is this one is hypotenuse, right? This is C. Then if this one 30 degree, then this one 60 degree. So the side which are facing opposite to the 30 degree would be half of length of hypotenuse. So this one, then this one would be this, right? Because you have to right? How we get this by using this kind of equation. This square plus this square equal to this square, right? But most important thing is this is half, which angle is like this side, it's opposite. It's opposite to the 30 degree angle, okay? Okay, so theorem. The length of the median hypotenuse of the right triangle equal to the half. Okay, that's easy. So basically it's trying, this is a hypotenuse, okay? He's saying if this is like middle point, so which means, let's say, this is A, B, C, this is triangle, right? So this point is D. How to get this D? BD is equal to DC. So this D is the point. It's the middle point, right? Make sure these two sides are the same. If you want to prove so AD is equal to BD equal to DC. If you want to prove that, how to prove this? It's very easy. So you want to, these three parts are the same. So if you want to prove BD, like this is ABD, this is a triangle. If you want proof BD is equal to AD, right? So which means you have to prove these two angles are the same angle, right? Do you guys learn about this kind of thing? Like if a triangle, if these two angles are the same, so which means this, like the side which composed these two angles, like this is like, so these two angles they share this side, right? But these two sides they don't share, but this angle are made of this side and this side, but this is a shared side, so we don't have to think about it. This is like these two are unshared side, but these two angles are the same, so which means these two sides, the lengths are the same. So the same thing, opposite would be the same thing, right? If you prove BD is equal to AD. So if you are say, if another like opposite would be the same, if these two sides are the same, so these two angles would be the same, right? If you want to prove AD is equal to BD. So which means you want to prove this angle is equal to this angle. Why? Because that's very easy. Because based on because this is triangle. So you can see if this is triangle, then right? Because this is triangle. So which means this angle plus this angle would be 90 degree, right? And then this is triangle. If this is triangle, so which means this angle. So this is equal to this, right? And then right, and then these two, add these two would be together, and let's see. So and then this is this side equal to this side, and then so which means this angle is equal to this angle, and this angle is equal to this angle. Then these two sides would be equal, right? So which means these three sides would be the same. Just remember that. Remember this kind of theory. If you don't understand how to prove it, you just remember for any triangle, if this D is the middle point, which equally separate BC into BD and DC. BD and DC is the same, which means you have those kind of theory. AD plus BD, AD is equal to BD equal to DC. Just remember that. We're gonna use it later on for the problems. And then let's talk about 6. 6 is interesting question. So he's saying this is triangle. B and B or B. Okay. And D is the any point in BC, and the E is any point. He's trying for you to prove. So AD square plus B square is equal to AB square plus DE square. Okay, how to prove it? So, okay, AC. Okay, he's talking about like, for example, this is triangle. Triangle ACD, because this is triangle. So if this is triangle, so which means CD square plus AC square, it's equal to AD square, right? And then there's another triangle, EBC. This one, right? And then which means right when you add these two together, so right? And then CD square root plus, and then he's saying, let me see. So we add these two together. AC equal to BC. Is this right? So this added together is AB squared. And then this is CE, and it's this one. So we can get to, so this is where we want to go. That's how we get it. So let's talk about number 7. Okay, so I don't think we need to talk about number 7. It's easy. Let's go direct to the example. Okay, the first one, the first example. Let me change to another pen. This pen almost. Is everything good? Because you guys never said anything. Is everything good?
Yeah.
Okay, let's keep going. Grace, is everything good for you? Okay, let's keep going. And then read the problem. How many of the following are true for right triangle ABC with two lengths, AB and so the first one, A plus B larger than C. That's normal, right? That's the any triangle will fit in that, right? Any triangle, no matter it's like 90 degree or non 80 degree, right? This is, but like for any triangle, right? We have A, B, C would always be like two sides added together should be larger than the third side, right? And then, okay, so this is A. So let's say the second one would be this angle plus this angle, right? So because this is 90 degree, so for the triangle, these three angles add together, it should be 180 degree, right? If this is 90, so which means angle A plus angle B will be 90 degree, right? Because angle C is also 90 degree. So the second one is right too, right? For the third one, it's normal, like these two leg square multiple together is the third side square, okay? And then for the fourth one, let's try to. So the fourth one is a little bit complicated. We can calculate because he wanted to see this, right? First, C square is equal to C. So this is, right, so this one would be, okay, so I'll do it, okay. And then we know, right? So this is, so from here, we convert to here because, so this one would be, and this one would be, that's all right, let's see. Okay. Okay, I want to see. Hold on. Am I confusing here? C is equal to this and this. Oh, okay. Okay. Not like this. I got confused a little bit. But like, for example, this is triangle. This is A, B, C. So this hypertenuse would be the longest one. So A and B. So convert here. So right, because C is the longest side, and then this is, so we can, so this is the fourth one, right? How to get, let's test the fifth one. Okay. This one. How to prove it, the sixth one. So how to prove the sixth one? Because how to get this one? Right? Because and then this one equal to, when they add together, it's this one. And then so you can convert from here, you can convert. Right. So so since this is some like something square, so this one it's minus, it's larger than 0, so which means, right, because this is minus, it's equal to this, and then this is, that's number 5. So then let's talk about example 2. So you want, so that's 2 square. Yeah, like this. Let me draw a little bit better. You want to get to know this. How did he do this? Let's say that's the center of this circle. And then here is the center of this circle. Since they are like, let's say, they interact together, this circle and this circle, when they link to each other, there's only one point. They only like get in touch with this specific point, right? And then, so they do like this. So this is 90 degrees. This is 90 degrees, right? This is like, for example, this radius, this one. This is the radius, this one. So we can get to know this radius for this one is 3. So this is 1. So we can get to know this one is 4, right? Because it's this radius of this big circle plus radius of the small circle, right? And then this is radius 2. So this is 3. This is 1, right? So basically, how to get this shape. So basically by using this big shape thing, this big shape area minus this shape, right? And then how to get the area for this kind of shape. So we can divide into 2 parts. So basically it's this kind of shape, right? It's a 90 degree. And then this is 1, this is 3, this is 4. You want to get to know, just divide into here. So So if this is 1, total this 1, 3, so which means this is 1, 2, right? This is 2 because they added together 3. And then this side would be using that theory. Right? Because this is C, this is A, this is B. So from this side, we can see this side is equal to 16. 4 square minus 2 square. That's it. Right? So this side will be this number. And then this area, the square is, right? Because that's a rectangle. This is a triangle. How to calculate this triangle? This triangle would be this side, multiply this side, divided by 2. Right? So the whole area would be these two added together. Right? And then we get to know. Now we have subject this part. So basically, right, this part. So for example, if this is 4, this is 90 degrees, this is 2, so which means this angle is 30 degrees, right? So which means this triangle is 30 degrees, right? And then this angle will be 60 degrees, right? This angle is this angle, right? So this angle. Well, that's big cycle. And then how to calculate the area of this part, because the whole cycle is pi r is equal to 3. That's pi r. And then the whole cycle, the whole thing is 360 degrees, right? This is only 60. So it's 60 degrees divided by 300 degrees. That would be, okay, it's this area. Because it's only like 1/6, only 1/6 part of the big cycle. So this is area for this one, all right? And for the same thing for this one. So you can see this angle, this is 90 degrees, and then it's 30 degrees added together. So this would be 120 degrees, right? 120 degrees, this one, right? So this is small cycle. So this is 120 degrees, right? And then the whole thing would be 360. And this 120, so 120 divided by 360, multiply. The area for this small cycle would be pi. This is 1, right? So this is pi divided by 3. So the total area would be the big thing, which is minus this small thing, this small part. 3 divided by 2 pi, and then plus this small cycle, this one. Okay, so I'm not further going calculate it. That's how it works. Okay, let's talk about next one. It's example 3. Let me see my screen. Make sure it's okay. Example 3. The two cycles are shown have the center C. So it's a big cycle and small cycle. They all have to share the same center C. AD is tangent to the inner cycle B. So, what's it mean? Tangent, which means the small cycle. When they interact, like cross cross with AD this line, they only cross with point B, right? So which means this is 90 degree. And then he's saying AB is 12. You want to know this shaft. So basically this shaft is equal to, let's say, the big one, the big cycle would be CD. Let's say it's R, okay? And then inner cycle would be BC, it's R, right? So the shade area would be pi, the big circle minus pi small cycle, right? And then this is R2. So, but you know, this is triangle. Triangle ABC is a triangle, right? So which means right? So this is the hypotenuse, right? This is one side, this is another side, and then this AB, right? Right, and then this shape, right? Right. So the answer would be A. And then let's talk about example 4. Example 4. Find the perimeter of the right triangle whose hypotenuse is 2 and whose area is 2. Okay, that's easy. So this is 90 degree triangle. This one is its hypotenuse is 2 and the area would be A and B. Right. The area would be A. Right. So from here we can get A multiple B is equal to 2. And another relationship here. This is C. This is 4. Right. Now you want to know the perimeter. Perimeter is like this. Right. We already get no C is 2. So basically we want to know this. Pay attention, these two square. So you can know this is 4 plus 1. What about 4? That's 18, right? So from here, we can get to know. So this would be 4. So the answer is B. Everything still good? Jamie?
Yeah.
Okay, let's keep going. We still have 30 minutes. Okay. So this one is easy. So like this. C, B, A, B. Okay. So this 3. This is 4. 12. Okay, this triangle. We need combine together. This is 3, 4, 5, right? Because right, and then this is 5, 13. Right? Remember triangle. Several example. 3, 4, 5. Another example. It's 5, 12, 13. Okay, so which means this is triangle. It's going to find the area. So it's basically this triangle area plus this triangle area. This one is 3 plus 6. This one is 30. So add together would be 36. Let's see. Okay. Let me talk about example 6. Okay, right triangle. ABC. Okay. Let's see. Let me see my screen. I always move my things around. Okay. So I want to make sure my screen is in the middle. No. Oh, no. I think this is good. Okay, this is good. Then we can move on the problem. So triangle. This is A, B, C. It's X, Y, Z. Right, it's a triangle. And then AC is the hypotenuse. Right, this is 2. And then X plus Y. It's AB and BC. And then this is triangle. We can also get to know. It's 4, right? Because this side is 2. We want to find out the area. So basically, how to calculate area is X multiplied Y and divided by 2, right? And then how to get this? Just from here. And get to know X plus Y squared is equal to 6. And this is X squared plus Y squared plus 2XY, right? This is 6, right? This is 4, right? And then from here, XY is equal to E1. This is half. So the answer is A. Okay, let's look at number 7. The perimeter of the right triangle. The perimeter is, let's say, this is X, Y, Z. So I know what it be 3 sides together. Right? And the length of the median to the hypotenuse. So we just mentioned about if this it's like a middle point. If this is middle point, and then we get to know AD equal to DC and BD, right? We just mentioned about, right? And then this is equal to 1. So which means this side is 2, right? And then we get to know Z. Z is 2, right? And then from here we can get to X plus Y. It's square root 6. And then X squared plus Y squared is equal to the other side is 4. You want to know the area of the triangle. So basically we have to get to know XY. Right? So from here we can convert into right. This X plus Y parenthesis square is equal to this number. We've got to know this is 4. So from here we get to know XY is 1. And then the area of this triangle would be. So how? That's B. Let's look at number 8. Okay, number 8. The perimeter of the right triangle, it's 120 inches. Okay. So with this triangle, this is 90 degrees, right? And then let's say, assume this is A, this is B, this is C. And then from the problem, we can see A plus B, A plus C, it's 120. And then the length of the attitude is this, right? It's 90 degrees. This one is 24. How many square inch are the area? Okay, so we also get to know, because this triangle, we also get to know this, right? We can get this one. And then for example, because this is a right triangle, so the area would be, right, because this triangle, and then the area of this right triangle would be also be this attitude multiplied this hypotenuse, right? So they would be the same, right? Triangle could be calculated this way. An area could be calculated this way. A multiplied B divided by 2. Also can be calculated by multiplication of attitude, multiply the hypotenuse, right? And then from here, we can get to know AB is equal to 24. C, right? And then you want to get to know the area. So basically you want to get to know much, right? So from here we get to know C is equal to AB divided by 24. And then we use this number. And then go to this. And go to this, right? And then when we use this, transfer this, A plus B is equal to 120 minus C, which is 120 minus AB 24, right? And then when we did like square to both of the side, right? And then this equal to A, right? This side, and this, and because this is equal to this, so this side would be become B and then from here we can get to know right, because this is when it's open, this one it'll be like this. You can cancel this and then finally become like this, and then C is equal to this number. C is equal to AB divided by 24. You make this number go here, right? So it's become right. Change it back. Maybe it's equal to right. The area would be 600. That's why you got 600. And then let's talk about next one. Which is next one? This next one is number 9. Grace, is everything good for you?
Yeah.
Okay, thank you. Let's keep going. Number 9. Okay. Okay. So and then the parameter. Let's say this side is A, this side is B, this side is C. The parameter of triangle would be, right? And then he said the middle point, M. This. So if this is a middle point, which means MA equal to MB, right? And then it's also equal to MC. Remember we just talking about? If this M is a middle point and then this side equal to these two sides. So which means this is 90 degree. So that's the theory we got. So from here, we can get this 90 degree. And then this is 5. This is 5. So which means this one is 10. Right? And then, so from here, we can get to know 24. And then also, beside this, so we want to get to know the area. So we want to get to know this. Right? So from this one, we get A plus B is equal to 14. And then this is this. Right? So from this equation, we can get to know A plus B parentheses square is equal to A square plus B square plus AB is equal to 14. This is like 196. And then this is 100. So which means this is AB is equal to 196. This is 48. So this is area. So this is 48. 24. Okay, so answer is B. Then let's talk about example 10. The length of the slide. Okay, one of that. Okay, so A, B, C, they are all integer. Okay, A plus B plus A square plus B square equal to C square because this is 90 degree. One of the leg is 13, so either one or B, it's 13. So what's the parameter? You want to know A plus B plus C, so much. So let's assume this side is B, right? So which means the hypotenuse C is equal to, right? It's equal to 13. Okay. Right. Let's say this side is C. So basically, no. Am I doing something wrong? Okay. Okay, sorry. And then we can convert this one. Right, so this is convert to so this C plus B must larger than C minus B, right? Because one is plus something, and then another one is minus something, right? And then so this like 13 square can be 1 multiple 169 can be 13 multiplied by 13, right? Like I just said, C plus B and C plus B, C minus B, they cannot be the same, right? Because B is not equal to 0, right? This is the length of the side of the right triangle. B cannot be 0, so must be like they are different. And then C plus B is larger than C minus B, so this is not an option. So we can get from here C plus B because A, B, C they are all integral, integer, right? Like so from here we can get to C is equal to 85. B is equal to 84. So the parameter would be 84. Right? This is C, this is B, this is A. Right. And then let's talk about next one. Okay. See. In a diagram. Okay. So let me draw it better. This is A, B, C, D. And these two angles, they are right angle, 90 degree. And then BD is 6 kilometer. This one is 6. Okay, AB is 3. DE is 5. So what's the number of kilogram in AE? Okay, so we can do like this way. We can do extension like this, right? You want to know the AE. So AE is basically okay. So if we extend this is an angle. If this is 5, right? So which means this side is 5 because they are rectangle, right? This is same as this one, right? And then BD is equal to, let's say this is F because this is a rectangle. This BD is equal to EF. This is 6, right? So we can get to know AE square is equal to AF. AF is 3 plus 5, that's 8, right? Is 6. So AE is 10. Easy. So when you're doing this kind of geometry problems, you have to know like how to extend. Sometimes like extend some kind of lines will make a much better mathematical model. Like for example, when you extend AB and get the F, right? And then it's easy to establish some kind of a right triangle AFE, which will make the way you solve the problem is much easier. Forgot. Okay. So in this kind of this is 90 degree. So this is like this. This is like this. That's not easy for me. Okay. This is D, C, E, A. Okay, so he said it's 6 degree. Right. And then, okay, this is 90, this is 90. AB is equal to 4. AD is equal to 5. You want to know BC divided by CD. So what did he do? So, okay. So the same thing, he extended these two lines. Oh, right. Make sure this line extension. And then since this is 90 degree, the 60. So let's say this is E, right? This ABE, triangle ABE, they are right angle, right triangle, right? And then 60, so this one 30, right? And then since this is 90 degree, so this is 90 degree too, right? So, so which means, so this is EC square is equal to, because it's a 90 degree, it would be ED square plus CD square. And then plus CD, let me see. Okay. Okay, EC. Okay, and then this is 30 degree, right? This is triangle. So this is triangle EDC. This is 90 degree. So which means this side, it's always be, now this is like hypotenuse of this one. So this 30 degree. So which means CD, it's equal to, right? Because it's 30 degree. This CD is the opposite side, facing this 30 degree, and should be half of the hypotenuse for this triangle, this degree. So EC is equal to 2 CD. So we put it back. So 2 CD. And then from here, we can get this out this square. Right. So ED is equal to square root 3 CD. ED with this part. This is right. And then he says CD. Okay. Let's see. Two CD, three CD. Okay. DE, how much is DE? Let me see. Oh, hold on. Sorry. Let's see. AE. Okay. Another thing is look at this big one, triangle. You pay attention to ABE. This triangle. This is triangle 2, right? This 60. This is 32. So this 30 degree opposite to this side. AB is equal to 20. the whole thing, right? AE, right? And then this is AB is equal to 4. So which means AE is 2AB. So which means this is 8. This is 8, right? Now this is 5. Because AE is equal to AD plus DE. Because this line is just the AD extension. And this is 8. And then this is 5. So which means ADE is equal to 8 minus 5. That's 3. And now from here, we already get to know DE is equal to 3. Only also equal to square root CD. So from here, we can get to know CD, it's square root 3 too. So, okay, now we get to know the CD, we have to know the BC, okay? Okay, that's easy. Like I just said, this is AB is a triangle, and then this side is 8, right? We just said, and this is 4. So which means BE is equal to, right? Because this is 90 degree, big one. And then this is 8, this is 4. So this would be, right? And then also, okay, we know this BE is 3, right? And then, okay. BE is 3. Okay, and then look at this EDC triangle. This EDC. This is 3, and this is 90 degree, this 30 degree, right? So which means we know CD is, right? Am I doing something wrong? That's not sure. Hold on, maybe I calculate something wrong. CD. I think I calculated something wrong. I got confused. Okay, CD is 30 degree. Okay, this is CD is, right? So this is, and then this is easy. This is hypotenuse, would be this side. That's this side. This is, right? So CE, this one is, right? And then we already get to know BE is 4. So BC is equal to BE minus EC, which is 1. So if you want to get to know BC divided by CD, will be equal to 2. Okay, so let's talk one more problem, then we end the class for today. Let's finish the example 13. Triangle ABC have the side ACBC AB measure. Okay, so A, C, B. Okay, AC is 18, BC is 24, AB is 30. Respectively, if D the middle point, B. Okay, so one thing we should pay attention. Is it 18? Right? So this is like, right? So So from these three sides, they add together, we can get to know this is 90 degree, right? And then if this is the middle point, so if this is 90 degree, this is the middle point of the hypotenuse. So we can get to know AD is equal to BD, it's equal to CD, right? So the first from these three sides, we assume as a right triangle. And then this is the middle point. We can assume these three sides would be the same. So would be 15. That's high. It's A. So I think I